polygon component is located right here. So you can basically create a polygon using the plane, which is the XY plane that I've given to this component like this, and you have the number sliders, so you can give it the radius, the number of segments you want, and the fillet radius. So as you can see, I have something like this over here. So the radius is 20, which controls the size. The segments, these are the number of segments that you give. So if I change it to 4, it will create a square. If I change it to 3, it will create a triangle. And if I create 6, it will create a hexagon. And the fillet radius is basically the corner fillets. So if I change this, you see how it's getting sharp and round like this. Now I'll just turn this off. Now let's take a look at the rectangle component. It's pretty much the same like the polygon. You have the plane, X and Y sizes of the rectangle and the radius. So if I turn it on, you can see I've created a rectangle like this, given it the XY plane. So that's why it's being created on the ground plane. And I've given it the X size, which is 20. You can control it like this. X size, which is the X-axis size. X-axis, the size which is in the X-axis direction. You have the Y size, which is the size in the Y-axis direction, the green direction. And you have the radius, which is these particular corners. You can change them like this, or keep it sharp if you keep it at 0. So I'll turn this off. Next we have a component known as interpolate. Interpolate is basically, say I have these random points like this. If you input these random points, and points are known as vertices, and if you give it a degree, now degree is basically, I can explain a degree once I turn this on. So say I turn this on. Interpolate is basically located over here, as you can see. And interpolate, what interpolate does is it takes a bunch of random points and it joins them up together. And you can change the degree of that. So if it's at degree 1, it will be, it will have sharp edges like this. It will join point to point. If it has a degree of 2, it will be a little bit more curvilinear. And as you can see over here, interpolation does not allow even degrees, but still it's giving us some kind of an output. If I change it to 3, nothing else happens. So you can pretty much give it 2 degrees, which is 1 and 3. And periodic basically means it will join the starting point and the ending point. So if I change periodic to true, and this particular component is known as Boolean toggle, you can just double click and type Boolean toggle and bring it in, or you can use it to actually find where it is located. It's located under parameters, under input. So it basically gives you 2 outputs, true or false. So if I double click and change it to true, you see how it joins the first point and the last point. And if I change the degree to 2, it creates more of a curvilinear join. And if I change the degree to 3, now this is not showing me any error, and this is what I'm getting. After interpolate, you have explode. So I'll just turn these things off. I have explode. So I basically exploded this curve. What explode does is it takes in a curve and it explodes it into segments and vertices. So if I turn this on, you see it took this particular curve and it exploded it into segments. Segments is basically all these lines, all these separate lines, and vertices is basically all the points. So after you have created something like this, now you see you don't have those many segments and those many vertices. But if I change it to false, now you see I have this particular segment or line and 2 vertices, first one and the last one. So basically I've exploded my curve into lines and points. So I'll turn this off. Now let's take a look at the NURBS curve component. The NURBS curve component, you can find it over here. Under curve and under spline, you can actually give it 3 inputs: vertices, degree, and periodic. It's pretty much these 3 inputs that were there under interpolate. So you give it some points, and you give it a degree, and you give it a periodic true or false based on what you want, and this is what you'll get. So if I change it to 2, it changes a little bit. Change it to 1, it becomes completely sharp, and 2 gives a little bit of curvature, and 3 gives it all-rounded curvature. And if you change this to false, it will basically open up on both the ends, starting and the ending point. And if you want it to be closed completely, you have to change periodic to true. Now I'll change it to polyline. Let's take a look at the polyline component. If you give it a bunch of points like this, you use the boolean toggle component to change it to closed or open, and it will basically give you a polyline. It's exactly like the nerves curve component, but it creates a polyline between all these points. So true gives you closed curve and false gives you an open curve. I'll turn this off. Now let's take a look at the tween curve component. Tween curve component basically creates a domain of a certain numbers and it tweens between two curves. So I'll turn on the two of the curves that I've created over here. So firstly, I've created these two curves that you can see on the screen, first one and the second one. I've created the tween curve component, which is located right here. Under curve, under spline, you can see tween curve. It takes in two curve inputs, curve A and curve B, and then it takes factors. So what you can input inside factor is the domain and the range. So in order to input range, you have to create a domain and steps as the number sliders. So these components I've already explained under the math tab. You have all these components over here. So what happens when you use the tween curve component is it creates an intermediate set of curves between the two curves. So if you were to change this curve into this curve, so how many transformations would it have to go through? That's basically what the tween curve component does. And you can change the number of curves using the domain start like this and domain end like this. And you can also change the steps, which is, these gaps, using this particular component. And if I change the location of one of these lines, then the tween curve changes accordingly. So tween is basically short for between, so it is basically giving you a bunch of curves between two random curves. So I'll turn this off. Next component is the offset curve. So offset curve basically takes in a curve like this and it will create an offset based on a distance that you can input through a number slider and a plane. So it will give you the offset of a curve on the XY plane. So it will give you the offset of a curve in the plane that you input. So over here, if you see, if I'm increasing the offset, it changes the shape of the curve based on the curvature of that particular curve on that plane. Since it's on the XY plane, it will give me the offset on the XY plane. Now I'll turn this off. Let's take a look at the project curve component. So we have already understood the concept of projecting and we have seen the project point component in the previous chapter. Now let's understand project curve. So say I had a curve like this on the bottom and I have a B-rep like this, or I have a surface like this, as you can see on the screen. It's a little bit twisted. What if I want to project this curve on this surface? So that's where the project curve comes in. It takes in a curve, takes in a surface or a B-rep, and it takes in a direction. So in this case, the direction is Z. Z because the curve is on the bottom and I want to project it on the top. You have to make sure that the curve exactly fits the size of your surface that you are projecting on. If the curve lies outside, then it will miss the particular projection. So if you turn this on, you can see that the curve is perfectly projected on your surface in the Z axis or in the Z direction. So I'll turn this off. So that's it for all of these components that were there in the curve tab. So under the curve tab, we have explored pretty much a lot of components, from discontinuity to perf frame, contours, lines, circles, arcs, polygons, rectangles, offsetting, tweening, and projecting some geometries onto other geometries. So in the next topic, we'll be taking a look at the surface tab.